सो आई विल एक्सप्लेन यू अगेन बिकॉज दिस इज समथिंग विच इज़ वेरी वेरी इंपॉर्टेंट, और अगर ये छोटी सी चीज़ इसमें समझ में आ गई देन इस पूरी यूनिट में बहुत ज़्यादा कुछ नहीं है. ओके, यू विल अंडरस्टैंड द होल यूनिट, यू विल बी एबल टू सॉल्व ऑल द क्वेश्चंस, नॉट ओनली फॉर दिस क्वेश्चन, आगे चल के जो रैंकाइन साइकिल में भी इसी के कंसेप्ट आपको काम आएंगे. ओके, सो क्या देखा हमने? सो इनिशियली द वाटर वॉज एट लिक्विड रीजन. ओके, वी आर हीटिंग दिस इज एब्जॉर्बिंग सेंसिबल हीट. Okay, then after that it is heated up to the point, up to the temperature which is called as the saturation temperature. Okay, at this saturation temperature this will convert from water to steam, and this is the region, as I told you, of the wet, this is the wet steam region, and after that it will be converted to superheated steam. Okay, so we will name this as A, B, C and D. Getting this? Okay, now as I told you, as we are increasing the temperature, जैसे जैसे टेम्परेचर की वैल्यू बढ़ेगी और जैसे जैसे प्रेशर की वैल्यू जैसे जैसे बढ़ेगी, if we are increasing the pressure, the saturation temperature also increases, as we have seen in the steam table. If the pressure is increasing, the saturation temperature will also increase. First thing. Second thing, if the pressure is increasing, the latent heat will decrease. Latent heat means this region from B to C, this region will decrease. Okay, so as the pressure increases, this curve will shift like this. Okay, the saturation temperature is increasing and HFG, the latent heat portion, is decreasing. Okay, and if we are joining, I am increasing the temperature further, I will get the curve like this. Getting this? So if I am joining all these points, okay, this is suppose A, B, C, D, then E, F, G and H, then I, J, K and L. Okay, so if I am joining all these locus of point J, F and B, and here K, G and C, I will get one dome shape. This is called as a saturation curve, and since this is a dome, that means at a point we will get one point where this HFG will be 0, latent heat will be absolutely 0. Okay, and at this particular point, as we are heating the liquid, at this particular point this liquid will be directly converted to superheated vapor, no region of wet steam. And this point, as I told you, is the critical point, and pressure at this particular point is critical pressure, temperature is critical temperature, and volume is critical volume. Getting this or not? Okay, so this is the first thing. Now next very very important thing, now just understand all these things very very carefully. The enthalpy at this particular point, this is the saturated liquid line. Okay, और इस saturated liquid line पे जो enthalpy है, that is nothing but HF. Okay, यहाँ की enthalpy को हम show करते हैं HF से, इस पॉइंट की एंट्रोपी को हम शो करते हैं SF से, वॉल्यूम को हम शो करते हैं VF से. ओके, एट ऑल दिस पॉइंट्स फॉर एनी प्रेशर, लेट सपोज दिस प्रेशर इज P1, तो P1 के करस्पॉन्डिंग इफ यू सी HF, you will get the enthalpy at this point, at point B. Similarly, let's suppose P2 pressure, if you see HF, you will get the enthalpy at point F and so on. Getting this? Okay, so at saturated liquid region, the enthalpy, entropy and volume, specific volume, are represented by HF, SF and VF respectively. Similarly, at saturated vapor point, this is a saturated vapor point, point C is the saturated vapor point. At this point, enthalpy is Hg, entropy is Sg and specific volume is Vg. That's it. Okay, at all these points, the enthalpy, entropy and volumes are represented with suffix G, and at all these points, saturated liquid point, enthalpy, entropy and volume are represented, or you can say any property is represented by suffix F, and you can directly see this value in this steam table. Okay, and the difference between the two is nothing but HFG. The difference between the two enthalpies is nothing but HFG, and this HFG is equal to Hg minus HF. Similarly, difference between entropy between 2 points, SFG is Sg minus SF, and VFG is Vg minus VF. Getting this? So I think all these things are clear. Okay, now if we want to determine enthalpies at each and every point, at point A, B, C and D, how can we determine? A is a point of pure liquid, B is saturated liquid, C is saturated vapor, and D is a superheated vapor. How can we determine the enthalpies at all these points? Okay, now we know the formula for change in enthalpy, del H. What is this del H? Del H is equal to mCp into del T, and if I want to calculate it for per unit mass, this would be del small s is equal to Cp into del T. We know the formula for change in enthalpy, but we don't know the formula for enthalpy, enthalpy at a particular point. Okay, so what we can do is, if we want to determine the enthalpy at point A, we can take one reference. Let's suppose we are taking 0 degree centigrade as a reference. ओके, तो 0 डिग्री सेंटीग्रेड वाटर को A डिग्री सेंटीग्रेड वाटर में कन्वर्ट करने के लिए जितनी हीट लग रही है, that is nothing but enthalpy at point A. What is the total heat required to convert a 0 degree centigrade water to A degree centigrade water? That is nothing but enthalpy at point A. Now, why am I saying this total heat required? Because this process is a constant pressure process, and as we know, in constant pressure process we have already studied that whatever is the total heat transfer at constant pressure process, that is nothing but the total change in enthalpy. Total heat transfer is at constant pressure process, Q is also mCp del T, as we know. Okay, that means at constant pressure process, whatever heat we are supplying to the system, the whole heat is used to increase the enthalpy of the system. At constant pressure process, total heat transfer is equal to total change in enthalpy. That's it. Okay, so how much heat is required to convert a 0 degree centigrade water to A degree centigrade water is nothing but enthalpy at point A. Similarly, enthalpy at point B, the total heat required to convert 0 degree centigrade water to B degree centigrade water or saturation temperature water is nothing but enthalpy at point B, and so on. Getting this? So, if I want to calculate this enthalpy at point A, we have to consider a reference point for this, because without reference we cannot calculate at any particular point. How can you calculate? You just have the formula for change in enthalpy, not just the enthalpy. So, we are considering 0 degree centigrade as the reference point. And finally, suppose if we want to calculate the change in enthalpy, it would be HB minus HA. We can just subtract this, and finally that 0 degree centigrade term will be cancelled out. Getting this or no? Okay, so this temperature at point A, sorry, enthalpy at point A, not temperature, sorry, enthalpy at point A is nothing but Cp into del T. Del T means temperature at point A minus temperature 0 degree centigrade. Getting this or not? Okay, similarly H at point B, enthalpy at point B, again this is nothing but Cp into Tb minus T0. Getting this? That means 0 degree centigrade water को B degree centigrade water में convert करने के लिए कितनी heat required है, that's it. Getting this or not? Okay, similarly enthalpy at point C. Okay, and one more thing I told you, that this enthalpy at point B is nothing but HF. We can directly calculate this enthalpy at point B, which is a saturated liquid point, from the steam table. Okay, so HB is nothing but HF. Clear or not? Okay, similarly if I want to calculate enthalpy at point C, what will be enthalpy at point C? Same thing, 0 degree centigrade water को C point C तक लाने के लिए कितनी heat लग रही है? Okay, 0 डिग्री सेंटीग्रेड वाटर को C डिग्री सेंटीग्रेड सैचुरेटेड स्टीम में पहुंचाने के लिए कितनी हीट रिक्वायर्ड है? दैट इज नथिंग बट एंथैल्पी एट पॉइंट C. गेटिंग दिस नाउ? तो 0 से लेकर B तक तो हमने देखा, दैट इज नथिंग बट HF. ओके, एंड देन व्हाट इज द टोटल हीट रिक्वायर्ड टू कन्वर्ट इट फ्रॉम B टू C? दैट इज नथिंग बट लेटेंट हीट, और जिसको हमने कहा HFG. ओके, सो एंथैल्पी एट पॉइंट C ऑब्वियसली इज इक्वल टू HF प्लस HFG. ओके, HF plus HFG, that's it, or you can also call it as HG. So this HG is nothing but HF, that means the amount of heat required to convert 0 degree centigrade water to 100 degree centigrade saturated steam. 100 degree centigrade saturated steam, इसको अगर मैं 0 डिग्री यहाँ कंसिडर करूँ, ओके, इस फिगर में शायद मैं ना बता पाऊँ, बाकी अगर मैं 0 डिग्री सेंटीग्रेड से अगर इसको कंसिडर कर रहा हूँ, तो फ्रॉम 0 डिग्री सेंटीग्रेड अप टू पॉइंट C, यहाँ तक की कितनी हीट लग रही है, that is nothing but enthalpy at point C. Clear or not? Okay, now this is also determined as this is also represented by Hg. Similarly enthalpy at point D. Okay, so same thing, 0 degree centigrade water को D degree centigrade superheated steam में convert करने के लिए कितनी heat required है? So this Hd will be equal to, so 0 से लेकर C तक हमको पता है, that is nothing but Hg. Okay, then from C to D, now this is a superheated steam, again for this you can calculate it as Cp into del T. So Cp will be taken for a steam, because here we are having the water in the steam form. Okay, so Cp of steam into Td. Okay, यहाँ तक हमने ले चुका है. Now we just want to calculate the change in enthalpy between C and D. So into Td minus Tc, or Tc is also equal to T saturation. Getting this or not? Okay, so this is how you can calculate enthalpies at each and every point, at point A, B, C and D. Clear or not? Okay, now let's suppose we are having some point somewhere here in the wet steam region. Let's suppose this point is E. inside wet steam region. Now how can we calculate the enthalpy at this particular point? Now just understand this thing very carefully. Now the total enthalpy to convert, let's suppose 1 kg of water from 0 degree centigrade, this everything I am referring to 1 atmospheric pressure. So don't take it as 0 degree centigrade, take it as saturation temperature. I am just simplifying this by saying it as 0 degree centigrade. Okay, so this I am referring to 1 atmospheric pressure because at 1 atmospheric pressure saturation temperature is 0 degree centigrade. Okay, so 100 degree centigrade water को 100 degree centigrade steam में convert करने के लिए कितनी heat लग रही है? That is nothing but latent heat, and what we represented as HFG. To convert 100% of water into 100% steam, total heat required is HFG. Getting this? Now if suppose we are converting just 60% of water into steam, okay, if suppose we are converting just 60% of water into steam, and here one term comes as dryness fraction. Dryness fraction, very important term. Dryness fraction, which is represented by x, and this dryness fraction is defined as the fraction which is dry. Okay, कितना fraction उसका dry हो चुका है, और you can say कितना fraction उस water का steam में convert हो चुका है. How much fraction of water is converted to steam? How much fraction of water is converted to steam is nothing but dryness fraction. Okay, so at any particular point, let's suppose at point E you want to calculate the dryness fraction. So how can you calculate? You will just see how much mass of vapor is there, mg. Let's suppose mg is the mass of vapor there, divided by total mass of mixture, which is nothing but mf plus mg. Okay, that means mf is the mass of water here, mg is the mass of air, and total mass is mf plus mg. Mass of vapor, not air, sorry. Okay, now if let's suppose I was giving you the example of 60%. Let's suppose 60% of the water is converted to heat, to steam. Okay, so what will be the dryness fraction in that particular case? 60% of water is converted to steam. Okay, suppose we are having 1 kg of water, and out of which 0.6 kg is converted to steam. Okay, so what will be the dryness fraction? This would be 0.6 divided by total mass is 1 kg, 0.6 plus 0.4. So this is nothing but 0.6. This is nothing but dryness fraction. Getting this now? How much fraction is converted to steam? How much percentage, you can say percentage, obviously you will have to multiply it by 100. You can, so how much fraction of that mass is converted, how much fraction of the mass of water is converted to steam, that is nothing but dryness fraction. Okay, now very important thing, if I know the value of this dryness fraction x, okay, now if I want to calculate the enthalpy at point E, okay, now very simple to calculate. Now enthalpy at point E means same thing, the amount of heat required to convert 0 degree centigrade water to E degree centigrade wet steam. Okay, and we know 0 से लेकर B तक की कितनी enthalpy required है, that is nothing but HB plus. Okay, now in order to convert from B to C, the total heat required or total enthalpy change is HFG. Okay, 100% convert करने के लिए कितना लग रहा है? HFG. 100% of water को steam में convert करने के लिए HFG. Now if let's suppose only 60% is converted to steam or X fraction is converted to steam, so obviously X fraction of this HFG will be required. Getting this or not? 100% convert करने के लिए HFG लग रहा है. If only X fraction is converted, so X fraction of HFG will be required. Getting this not? Okay, so B से लेकर E तक की enthalpy change कितनी होगी? That is nothing but X into HFG. That's it. And this HB, as I told you, is HF. So this HE will be equal to HF plus X HFG. Very, very important thing, very important formula. If you want to determine the property of wet steam region, enthalpy at wet steam region is H is equal to HF plus X HFG, where X is the dryness fraction. Getting this? Similarly, entropy of wet steam is equal to SF plus X SFG, and specific volume of wet steam VE is equal to VF plus X VFG. Now this VFG can be written as VG minus VF, as I told you, and this VF, the value of this VF is very, very small, almost 0. If you want, you can see in the steam table, it starts from 0.000 something. Getting this? So this can be neglected in most of the cases. So this can be taken as directly taken as VF plus X into VG. This is the reason why in most of the steam table the value of VFG is not given, because you can directly say that VFG is equal to VG. So enthalpy of wet stream HF plus XHFG, entropy of wet stream SF plus XSFG, and specific volume is VF plus X into VG. This is how we can determine the properties of the wet stream, and this is how we can determine the enthalpy at each and every point. Getting this or not? Okay. Now let us look into the change in entropies in various phase changes or various processes. Okay. So in process in process A to B, okay, where we are having the pure liquid at A degree centigrade, which is converted to the saturated liquid at B degree centigrade or saturation temperature. Getting this or not? What will be the change in entropy in this particular case? Del S BA. Okay. Change in entropy. So as we know, the formula for change in entropy, if we are having a constant pressure process, then del S is equal to what? Del S for constant pressure process at pressure is equal to constant, as we know, is mCp ln of T2 by T1, T final by T initial. Okay, so just put the formula. So this del S BA is nothing but mCp, taking for per unit mass, this will be equal to Cp ln of Tb by Ta. Okay, this temperature will be taken in Kelvin. Just remember this thing. And Cp ln of Tb by Ta. Getting this or not? Okay. Similarly, now the change in enthalpy from B to C, del S Cb. Okay. Now what is the value of this change in enthalpy when 100 degrees centigrade at 1 atmosphere, 100 degrees centigrade of steam is converted to 100 degrees centigrade of water is converted to 100 degrees centigrade of saturated steam. Then what will be change in entropy, sorry. Del S Cb. Okay, so this del S Cb, now because the temperature is constant here, okay, temperature is constant, so as we have seen at constant temperature process, total del S is nothing but Q by T. Okay, and what is total heat transfer during this process? So in this process, as we know, total heat transfer is nothing but HFG. Change in enthalpy at constant pressure process, total change in enthalpy is nothing but HFG, and change in enthalpy is nothing but total heat transfer. Getting this or not? Okay, so this del S Cb is nothing but Q by T, or you can say this will be equal to HFG divided by T, and T is nothing but T saturation temperature or temperature at point B. Getting this or not? Okay, similarly del S Dc. Okay, again we are converting the steam at point C, the saturated steam at point C, to a superheated steam at point D. What will be the change in entropy now? So same thing we have to do. Now here this will be equal to Cp ln of T final by T initial. T final is nothing but Td. T initial here is nothing but Tc or saturation temperature. Okay, and this Cp is nothing but Cp of steam. Okay, so don't get confused. Here this was Cp of water because this was in water phase. So here we will use Cp of water, not for the air, not for the gas. This is for the Cp of water. And here we will use the Cp of superheated steam, Cp of steam ln of Td by Tc. Okay, so this is how we can calculate the change in entropy at various points. And if we want to determine entropy at point E, as I told you, this Se was equal to this Se was equal to Sf plus X SFG. That's it. Okay, so this is how we can calculate entropy or change in entropy at various points. So this was a change in entropy in various processes. Now if I want to calculate entropy at a particular point, so Se, as I told you, is Sf plus XSFG. We have already seen. What will be Sa? So again, since we will take 0 degree centigrade as reference, so 0 degree centigrade water को A degree centigrade water में convert करने के लिए कितनी entropy change हो रही है? That is nothing but entropy at point A. Similarly, 0 डिग्री सेंटीग्रेड वाटर को B डिग्री सेंटीग्रेड सैचुरेटेड वाटर में कन्वर्ट करने के लिए कितनी एंट्रोपी चेंज हो रही है? दैट इज नथिंग बट एंट्रोपी एट पॉइंट बी. गेटिंग दिस नॉट? तो SA इज नथिंग बट Cp ln ऑफ TA बाय T0 डिग्री. दैट मीन्स 273 केल्विन. Getting this not? Similarly, SB, same thing. SB is nothing but Cp ln of TB by T0 degree centigrade. Getting this? What will be SC now? So SC, as we know, and this SB is nothing but SG. Okay. What will be SC? SC is nothing but SG plus SB is nothing but SF, not SG. This SB is nothing but SF. Okay. Now what will be this SC? This SC is nothing but SF plus SFG. Okay. SC का मतलब 0 डिग्री सेंटीग्रेड वाटर को C डिग्री सेंटीग्रेड सैचुरेटेड स्टीम में कन्वर्ट करने के लिए कितनी एंट्रोपी चेंज हो रही है. सो दिस SC इज नथिंग बट SF प्लस SFG, एंड दिस कैन बी ऑल्सो रिटन एज SG, एज आई हैव टोल्ड यू. गेटिंग दिस? सिमिलरली एंट्रोपी एट पॉइंट D, Okay, this will be equal to, so 0 डिग्री सेंटीग्रेड वाटर को d डिग्री सेंटीग्रेड सुपरहीटेड स्टीम में कन्वर्ट करने के लिए. So up to point C we know this is nothing but Sg, and after point C from C to D we know the change in entropy which is nothing but Cps ln of Td minus Td by Tc. So this will be equal to Cps ln of Td by Tc. This is all is for in the unit of every change in entropy here, or entropy is nothing but kilojoule per kg Kelvin. If I multiply it by mass, I will get it in kilojoule per Kelvin. Getting this now? So this is how you can calculate the entropy at each and every point.